So here we are going to discuss some concepts from 5.6. If you were absent yesterday, I had the classes take notes, their own Cornell-style notes on 5.6. So you will have to do that independently. But we are just going to take some time to discuss those concepts to make sure that you do actually understand what you took notes over. So this begins our study of inequalities and graphs of inequalities. So this first set of problems, I'm only going to do one of them to give you an idea of what to do. It says, tell whether the ordered pair is a solution of the inequality. You're simply checking by plugging in whether or not you get a true statement. If it's true, then yes. If it's untrue, then no. So let's just do number 4. I'm going to take 5 and negative 7, and I'm going to plug that in for x and y respectively. Negative 2 times 5 minus 3 times negative 7. I'm going to evaluate or determine whether or not that is less than 15. So I have negative 10 plus 21. Remember, your negative times your negative yields a positive. So when I add those two, I get 11, and that is, in fact, less than 15. All right, do you have any questions? Very simple concepts. If you miss any of these notes, feel free to go back and watch the video for the complete bell work, but I am expecting 1 through 4 on your bell work here. These are the answers to 1 through 4. No, no, yes, no. I meant to say no, no, yes, yes. All right. So we're gonna look at graphing the inequalities in a coordinate plane. Your book talks about testing values, and that is definitely true. You can test the value 0, 0. When can you not test the value 0, 0? Yeah? If you graph a line, and we test values to determine the direction that we shade. If you graph a line, this is the line y equals x, we see that the line is on or crosses the point 0, 0 at the origin. Anytime it crosses the point 0, 0, I cannot use that as a test to determine where to shade. So for example, on number 5, it says graph the line y is less than negative 1. The first thing that we're going to do is determine whether or not the line that we graph is going to be solid or dotted. Based on the notes that you took yesterday, is that going to be a solid line or a dotted line? It will be a dotted line. Perfect. So when we see just less than or greater than, that's a dotted line. As soon as we put that bar underneath for less than or equal to or greater than or equal to, then it will be a solid line. When you want to test a value to determine the direction in which you want to shade, you're going to test the point 0, 0. This line does not lie on the point, or does not cross the point 0, 0. So if you just input 0, and you determine whether or not that's a true statement, is that true? Yes, it is. So when you graph this line, let's say it's down here in blue. Remember, that's a horizontal line, and you want to shade. You simply shade towards that point 0, 0. And I'm actually going to teach you a simpler way to do it, okay, than what your book says. The easiest way to figure out where to shade is the direction of your inequality. If it is towards the y, and I would write this down, I'll do different scenarios. If it's towards the y, away from the y, towards the x, or away from the x. If it's towards the y, you always want to shade above your line. If it's away from your y, you always want to shade below. You don't even have to test values. This will always work. If it's towards your x, you want to shade to the right. If it's away from your x, you want to shade to the left. All right, so let's go ahead and determine how we're going to shade each of these. So number 5, we've already looked at. Is that going to be above the line that we're going to shade or below? Above. If it's towards the y, it's above. Okay, is that solid or dotted? Dotted. So it's above and it's dotted. What about number 6? Is that to the left or to the right? Left. Is it solid or dotted? Solid. Number 7. Do you think that's going to be above or below? Below, right. Because if you get the x to the other side, we simply have y is less than or equal to negative x minus 4. We graph those lines as usual. The only difference is if those lines are solid or dotted. So since it's going to the left of y, we know it's going to be below. And it's also going to be a solid line. Now this one, number 8, is a little tricky. So when we try to get y by itself, when we isolate that variable and I subtract x on both sides, subtract x, what I end up with is negative 2y is less than negative x. What happens when I divide by that negative 2? I flip the inequality. So negative 2 divided by negative 2. Okay. And so I end up with y is now greater than 1/2 x. So is that above or below? You're going to shade above your line, and that's going to be solid or dotted? Dotted. All right. Let's check all of these. All right. Number 5, we said it was above and dotted. 6, we said it was to the left and solid. Now, what's the point of the dashed lines? Well, just like we had open circles and closed circles, we remembered that open circles did not include the value. So if I had, for example, x is less than 4, then it was only numbers less than 4 for my solution, not including 4. But if I had less than or equal to 4, it was 4 and anything below it. This was an open circle, this was a closed circle. The dashed line is similar to that, meaning that if we're looking at solutions, values to test, I cannot pick any values on this line to get a true solution. It will lead to a false solution. It will not be a solution, right? So I shouldn't say false solution, it would just be false. Okay. Let's take a look at the next two. Okay. Number 7, this was below. Solid. Number 8 was above. Dotted. Do you have any questions about that? Okay. So, somebody had a question on number 8. Okay. going back to that problem, it was y is greater than 1/2 x. Since y is greater than, that means I'm going to shade above my line. If the above and below thing is confusing to you, then you can simply test values. I cannot test any values that are on the line itself, so I cannot pick 0, 0 in this instance. I can pick, for example, 0, 1, and see whether or not that's true. If it's true, then I shade towards that point. So, 0, 1. Is 1 greater than 1/2 times 0? Well, yeah, it is. 1 is greater than 0. So I'm going to shade towards the value 0, 1. A couple different ways you can do this. It just depends on what you're comfortable with. All right. So anyway, hopefully you didn't hear that. Write an inequality that represents the graph. So you will have to use your graph to write an inequality. So we're just writing the equation of the line, and then we will, lost my train of thought. I was kind of caught off guard. Okay, so let's first of all figure out what our y-intercept is of that line. What is our y-intercept? -2. This will be an interesting video to look back on. V is equal to -2. Okay, now let's look at our slope. Let's find our slope. What is our slope? -1/2. Perfect. So again, you can just go down 1, over to the right 2. So that's a slope of -1/2. Not -1/2 x. Now typically, we would write the equation of our line like this. We would say that y equals -1/2 x minus 2. Well, we have to decide our inequality. First of all, it's solid, right? So it's either going to be this, less than or equal to, or greater than or equal to. Now, is the shading going above the line or below the line? Below the line. So that means that I'm going to write it away from the y, just like that. And it's going to be y is less than or equal to -1/2 x minus 2. Okay. Do you have any questions? All right. Thank you. So we're going to look at this example for modeling with mathematics problem. It says you can spend at most $10 on grapes and apples for fruit salad. Grapes cost $2.50 per pound and apples cost $1 per pound. Write and graph an inequality that represents the amounts of grapes and apples you can buy, identify, and interpret two solutions of the graph. So I went ahead and graphed it for you. A couple things that you want to note about this graph, again, is how we are labeling our x-axis and our y-axis. In any type of modeling problem, the expectation is that you are labeling those axes. Also note, in these word problems, we will be using, more often than not, just the first quadrant because we can't get any negative values. So, let's set up an equation based on the context of this word problem. It says grapes cost $2.50 per pound. And apples cost $1 per pound. We can spend at most $10 on grapes and apples. That phrase, at most, indicates that I have to use some sort of inequality. Represent the situation, model the problem with some sort of inequality. At most. So that means I can I spend more than $10? No. I can spend $10 or less. So, $10 or less would look like that, correct? So we simply have to isolate the variable y by subtracting 250 and subtracting 250x. When we do that, we get y is less than or equal to negative 250x plus 10. You would graph that in the first quadrant. Your y-intercept is 10. And of course, on these word problems, we'll apply the same strategy that we looked at yesterday when we were looking at the word problems for extra credit. 0, 10 is a y-intercept. And then I'm just going to find my next point by using that slope to help me out. That slope says I'm going to go down to 50 and to the right 1. So if I go to the right 1 and down to 50, what's my next point? Subtract 2, that's 8, subtract 0.5. Yeah, 7.5. So 1, 7.5. Right? And then I could go to the next one. What's my next one? 6. If you're going down 250, wait a minute. If you're going down 250, 5, right? 2, 5. Which you can see 2, 5 is this point right here. Again, we're shading, and we find that any of these values in our shaded region will make this inequality true. So they put the value 1, 6, for example. If you plug in 1 for x and 6 for y, it will indeed be less than or equal to $10. So you can buy 1 pound of grapes and 6 pounds of apples. And then you can pick another solution in the shaded region, and that will work as well. 1 pound of grapes and 3 pounds of apples. Any questions? No? All right. For those of you who are absent today and you're watching this video, I apologize for some of the snafus, but it happens. This is your updated table of contents. This item was from yesterday, number 13. The bell work 1 through 9 was from today. If you didn't get all 9 items in class, then of course go back and rewatch the ones that you didn't get to finish. But do have all 9 items for bell work. Label that 12-9. So do try, if you're keeping up with this table of contents, to have 5.6 completed by Monday. Just a reminder, your test is on the 15th. That is when your assignment packet is due. Also, your notebook check is the review day before that, so on the 14th. All right.